This is the 9th video of the topic series differentiation. In this topic, we are going to discuss about the chain rule in differentiation. What do you mean by this chain rule? We know that our usual notation for the differentiation of a y would be dy by dx. The chain rule says we can get dy by dx by multiplying dy by du into du by dx. What do you mean by dy by du? That means a y function differentiated in variable of u. That means y should be given in variable of u into what do you mean by du by dx? That means the function u is differentiated in variable of x. That means for this purpose, the function u should be in terms of x. For this, the function y should be in terms of u. Take this thoroughly into your mind. Means the y is a function of u terms and u is a function of x term to obtain this equation. Right. Let's go ahead with this example. Given that y equals to 3x to the power 4 plus x to the power 5, find dy by dx using the chain rule. This is pretty simple. Initially, assign the term inside the bracket as u. This is the usual technique where we used to do it. Right. Then first you have to take the term inside the bracket as u. Then it's a then you can understand that u become a function of x. Then you obtain the differentiation of u in terms of x. Again, du by dx. If you differentiate it, what do you get? 3x to the power 4 differentiation is 3 into 4, that is 12, x to the power 3 plus x differentiation is 1. Okay. Then we know that if I take this term as u, this function turn up into y equals to u to the power 5. Y equals to u to the power 5. Then you know that y is a function of u. Therefore, you can write dy by du. This is not dy by dx. What is the reason it's not dy by dx? Because the function is u in terms of u. Then you can write this is dy by du. If you differentiate it, what do you get? 5u to the power 4. Right. Our objective is to find dy by dx. Then I can write dy by dx equals to dy by du into du by dx. The chain rule what we have used over here. Right. Okay. Then what is dy by du? That is 5u to the power 4 into what is du by dx? 12x cubed plus 1. Then we know that u is how much? U is 3x to the power 4 plus x. Then you can write 5 u to the power 4 is 3x to the power 4 plus x to the power 4. This came because you already substitute this figure into 12x cubed plus 1. This is the final answer of the differentiation of y equals to 3x to the power 4 plus x to the power 5. Let's move up to this example. We need to differentiate sine x to the power 4. Then this is sine x whole thing to the power 4. Then I will assign this sine x as u. Then u equals to sine x. Then we can obtain du by dx. Remember that always this term should be the variable term over here. Du by dx. If you differentiate sine x, we already knew from previous videos, it's cos x. Right. Then if I substitute u equals to sine x, this turn up into y equals to u to the power 4. Then I can differentiate dy by du. If you differentiate this, what do you get? 4u to the power 3. From chain rule, you can write dy by dx equals to dy by du into du by dx. Dy by du is 4u to the power 3 into du by dx is, cos x. Right. Then we know that u is sine x. Therefore, you can write 4 u is sine x to the power 3 into cos x. That is the answer of the differentiation of y equals to sine to the power 4x. Let's try to verify from these examples. We need to differentiate. We have to find dy by dx for 1 plus 2x to the power 4. Initially, I'll take this one as u. Then it will turn up to, if you get du equals to 1 plus 2x, differentiation would be 2. Then the y turn up into u to the power 4. This is, I have assigned it as u to the power 4. Then the differentiation of dy by du become 4u to the power 3. Then we can write dy by dx equals to dy by du into du by dx. We know that dy by dx is 4u cube into du by dx is 2. That is 8u cube. We know that u is how much? 1 plus 2x. Therefore, you can write the differentiation of 1 plus 2x to the power 4 is 8 times of 1 plus 2x to the power 3. Right. The next extension, we need to obtain the differentiation of 3 minus 2x squared to the power minus 5. Initially, we will take this one as u. If this is u, differentiation of u by x, du by dx become, if you differentiate it, what do you get? You get minus 4x. Then, if I substitute u over here, that is y u to the power minus 5. If you differentiate it, what do you get? Minus 5 u to the power minus 6. From chain rule, you can write dy by dx is equals to dy by du into du by dx. That is 5u to the power 6 dy by du into du by dx. U to the power minus, it should be du by dx is minus 4x. Then this is 20x u to the power minus 6. Now you know that u is how much? U is 3 minus 2x to the power 2. So if you replace u with this term, you will obtain the answer 20x 3 minus 2x squared to the power minus 6. The next one is we need to differentiate 3 plus 4x to the power half. Initially, what you need to do, take this one as u. Then if you differentiate du by dx, answer is 4. Then this term, this expression turn up into y equals to u to the power half. Then you can get du by dy by du, dy by du. If you differentiate it, what do you get? You get half u to the power minus half. This is minus half. Then if you use a chain rule, dy by dx turn up into dy by du into du by dx. That is, dy by du is half u to the power minus half into du by dx is 4. Then if you simplify this, 2u to the power minus half. If you simplify this, then 2, what is u? U is 3 times 3 plus 4x to the power minus half. That would be the answer for that, right? Let's come up to question number D, right? We need to differentiate 6x plus x squared to the power 7. Initially, what you need to do, take this term as u, right? Then du by dx turn up into 6 plus 2x. Then this term turn up to y equals u to the power 7. Differentiation is 7u to the power 6. So du dy by du is 7u to the power 6. dy by dx is equals to dy by du into du by dx. dy by du is how much? It's over here, 7u to the power 6 into du by dx, 6 plus 2x. Then instead of this, you can replace with 6x plus x squared. Then you can get the answer 7, 6 plus 2x into 6u is 6x plus x squared to the power 6 would be the final answer. Right. The next value we have to differentiate is y equals to 1 over 3 plus 2x. Initially, we have to take it up and you can write 3 plus 2x to the power minus 1. Because chain rule we can apply for a function of x to the power n, right? Then we will take this term as u. Therefore, du by dx turn up into 2. Then this expression turn up into y equals to u to the power minus 1. If you differentiate u to the power minus 1, answer is dy by du equals to minus u to the power minus 2. Then we can apply the chain rule. Dy by dx is equals to dy by du into du by dx. Dy by du is how much, children? Minus u squared. Minus u to the power minus 2, sorry. Into du by dx is 2. Then this is minus 2. U to the power minus 2, you can write 1 over u to the power 2. What is u? 3 plus 2x. This is turn up to 3 plus 2x to the power 2. So if I repeat it, You can write this is minus 2 over u to the power 2 by the denominator because this is a negative power. U is 3 plus 2x to the power 2. Right? Then let's come up with question number F. Right. The function we need to differentiate is y equals to square root of 7 plus x, right? So if you do this differentiation, we can write initially, before you differentiate, you can write in power form 7 minus x to the power half, right? Then you can take this term as u. That means this is u to the power half, right? Okay. If you differentiate u, du by dx is, if you differentiate this, what that answer? That is 10 up to minus 1, right? Then y equals to u to the power half, right? If you differentiate this, what do you get? You can write dy by du is equals to half u to the power minus half, right? Then dy by dx is dy by du into du by dx. Dy by du is how much, children? Half u to the power minus half into du by dx is minus 1. Then half into minus 1 is minus half. This is u is 7 minus x to the power minus half. You can write the negative powers by brought them into the denominator. So you can write this is 1 over 7x to the power half is square root of that, right? That's the answer for that question, right? Then if you come up with this question, y equals to 4 times of 2 plus 8x to the power 4. Initially, we will take 2 plus 8x as u. Then du by dx would be 8. Then this term turn up into y equals to 4u to the power 4. Then you can get dy by du. If you differentiate it, what do you get? 16u to the power 3, right? Then dy by dx equals to dy by du into du by dx. dy by du is 16u to the power 3 into du by dx is 8. That is 128 u to the power 3. What is u? U is 2 plus 8x. Therefore, you can write this is 128 times of 2 plus 8x to the power 3. Okay. If you come up with question number H, y equals to 3, 8 minus x to the power minus 6. Initially, we have to assign this one as u. So you can write this is 3 u to the power minus 6. Then we can write du by dx over here. Then if you differentiate it, what do you get? Minus 1. Then if you differentiate this, what do you get? 3 into minus 6 is minus 18 u to the power minus 7. From the chain rule, you can write dy by dx is equals to dy by du into dy by du by dx. Sorry, dy by du is how much, children? This bit. And du by dx is this bit. Then minus 18 into 1 is 18. U to the power minus 7. What is u? U is 8 minus x to the power minus 7. If you want, you can write this is 18 divided by 8 minus x to the power 7. If you want, you can write it, but this one also fine, right? Okay. Then this is the other important topic where we need to understand. Actually, we use this composite version of the chain rule. For the moment, we have differentiated functions y equals to some function as x. But there are some situations we come across, you get a function of x in terms of y, right? In such situation, if you want to find dy by dx, we use this composite version of the chain rule, right? Let's come up with this. Yeah. Before we come up with that, you have to understand that we can write dy by dx as 1 over dx by dy. Dy by dx, you can write 1 over dx by dy. Let's see how to use this composite version of the chain rule for our calculations, right? They have given us x equals to y squared plus y. Find dy by dx. To find straightforward dy by dx, this is not a function of y and this is not a function of x. This is not y equals something. This is x equals some function of y. Straightforward, we cannot find dy by dx, right? But later on, there are some techniques we use that is called implicit differentiation. We will learn from further topics of differentiation how to do is without this composite version of chain rule, right? Initially, we will differentiate dx by dy. Why are supposed to get it as dx by dy? Because it's a function of x is a function of y. Then you can write dx by dy. If you differentiate y squared, answer is 2y. If you differentiate y, answer is 1. Then we can write dy by dx is 1 over dx by dy. That is 1 over what is dy? Dx by dy. Dx by dy is 2y plus 1. That is the answer for this. Okay. Remember that from this fact we get a function of y, right? Let's come up with the next one. This one is x equals to y squared plus sine y. This is a function of y. X is a function of y. In our previous examples, somewhere over here, you can say y is a function of x. But in this situation, you can understand that x is a function of y. Then we can, our question is dy by dx. Initially, we can find dx by dy. Y square differentiation is 2y. Sine y differentiation is cos y. Then we can write dy by dx is 1 over dx by dy. That is 1 over, what is dx by dy? Is 2y plus cos y would be the answer. Right. Let's come up with these examples. First question is x equals to y squared plus y. We need to find dy by dx. We can find dx by dy. Y squared differentiation is 2y. Y differentiation is 1. Dy by dx is 1 over dx by dy. Therefore, you can write 1 over what is dx by dy? It's 2y plus 1. Right. If you come over here, x is e to the power y plus 4y. If you differentiate dx by dy, ey differentiation is ey. Later on, you will understand the differentiation of exponential function would be the same thing itself, right? 4y differentiation is 4, right? Then dy by dx is 1 over dx by dy, that is 1 over e to the power y plus 4 would be the answer, right? Then, if you come up with x equals to sine 2y, we can find dx by dy. If you differentiate sine 2y, what is that answer? That is cos 2y, then differentiation of 2y is 2. That is turned up to 2 cos 2y. Then dy by dx is 1 over dx by dy. That is 1 over dx by dy is how much, children? That is 2 cos 2y. That turn up into 1 over cos 2y is sec 2y, and 1 over 2 sec 2y came in that way. Other than that, you can write 1 over 2 cos 2y over here. The next question is we need to find the dy by dx of 4x equals to ln y plus y cube. Initially, we have to subject x. Then you can say x equals to 1 over 4 ln y plus 1 over 4 y cube. Then we can find dy by dx. So you can keep 1 over 4. Ln y is 1 over y. So this answer turn up into 1 over 4y plus 1 over 4y cube. If you differentiate it, what do you get? 1 over 4 into 3y squared. That is 3 over 4y cube. Then if you want, you can take the LCM. If you take the LCM, it will turn up to LCM is 4y, 1 time plus 3 into y squared into y, that is 3y cube. So this is the answer. Then dy by dx become 1 over dx by dy, that is 4y. If you write 1 over 1 plus 3y cube over 4y, you can write it as 4y over 3, 1 plus 3y cube. That means 1 over 1 plus 3y cube over 4y. This 4y come up, and you can write this answer over here. Right? That is the way of using the chain rule and the composite version of the chain rule in our applications of this differentiation.